Hello learners, today we want to look at the basic aspects of applied chemistry. And the basic aspects of applied chemistry begin with what is an atom and what are the characteristics of an atom. And to know what is an atom, we must define what is mass. Mass is anything that has weight and occupies space. All matter is made up of atoms, and atoms are the building blocks of matter. For instance, when you are building a house, you start with one brick. One brick in this case is just like an atom. It is the building block of a house. So, an atom is the building block of any matter. After defining what is an atom, we need to know how an atom came into being. There are several theories that brought about the existence of an atom. The first one we need to look at is the John Dalton theory that was developed in 1776 to 1884. In this theory, Dalton said that all matter is made up of atoms. And atoms, when there are many, they make up what we call as an element. An element is something that has got a combination of identical atoms. Each of the element has got each and specific element has different atoms. Atoms can engage in a chemical reaction to form what we call as compounds or chemical compounds. Atoms can neither be created nor destroyed, and this is what we refer to as the law of mass conservation. Apart from the John Dalton theory, there is what we call as the Rutherford's atomic theory, which was developed thereafter the Dalton's theory in 1871 to 1937. In this case, Rutherford saw that an atom is positively charged and is located at the central part, which we call, and has got a central part, which we call a nucleus. Around the nucleus are distributed electrons. Electrons, therefore, are moving around the nucleus. The mass of an atom is usually concentrated at the nucleus. However, the weight of an atom or the volume of an atom compared to the volume of a nucleus is quite small. That was the summary of Rutherford's theory. But when we look at Rutherford's theory, it can be compared with the solar system, where we say at the central part we have got the sun, and around it are some of the planets we know, and they are moving, rotating around the sun. The same way in Rutherford's atom model is that at the central part we have got what we call as the nucleus that is positively charged. And around the nucleus are some moving electrons. They are found in various orbits. There is also what we call as the Bohr's model of an atom, which was developed in 1913. In this case, Bohr observed that electrons are found in orbits and the nucleus are like planets orbiting around the sun. This is what we call as the solar system. In the solar system, we said, just like an atom, the sun is in the central part, which is occupied by the nucleus in the case of the atomic theory. And around it are what we call as the planets. In the case of an atom, are what we call as electrons. Therefore, the nucleus is positively charged and has got what we call as the protons that are positively charged. It also has got some neutrons, and neutrons do not have a charge. Therefore, the overall charge of the nucleus is positive. Around the orbits of we have got what we refer to as electrons. The electrons are negatively charged. Remember we said that opposite charges attract each other. Therefore, the nucleus usually attracts the orbit, and this is what holds an atom together. Remember, when we were defining an atom, we see that it cannot be divided further, and this is as a result of the attraction between the positive nucleus that consists of protons and the orbits that consists of negatively charged electrons. The Bohr's theory also showed that electrons are filled with orbits. Electrons normally first fill the orbits that are closest to the nucleus. However, as we will see further, is that usually this is the orbit. The first nucleus is first filled with electrons before going to the next one. This is in the case, like in the case of fluorine. Fluorine has got 10 neutrons and has got 9 protons and has got 9 electrons. Usually, the first orbit is the one that is filled with electrons before moving to the next shell. In the Bohr's theory, it also said that each orbit can hold only a specific maximum number of electrons. For instance, in any atom, there are 4 shells. The first shell is what we call as the K shell and can have a maximum of 2 electrons. This is what is filled first. Next is the second shell, which we call as the L shell and can only occupy a maximum of 8 electrons. Thirdly, we have the M shell that can occupy 18 electrons. The other shell is the fourth one, which is known as the N and can occupy 32 electrons. Usually, we fill the K before the L and L before the M and N before the M. That is according to Bohr's model of an atom. So what do we see using the Bohr's model is that it has got a nucleus at the center, which has got both electrons and protons, which has got both, at the center we see the nucleus. It has got neutrons and protons. Neutrons do not have any charge. Protons are positively charged. Therefore, the nucleus is positively charged. Around it are what we call as shells, or what we are calling as energy levels. And these energy levels can only hold a specific number of electrons. We say the first one can hold 2, while the other one can hold 8, and the other one 18, and the other one 32. And these electrons normally are orbiting around the nucleus. So, what is the structure of an atom after understanding what are the various aspects of an atom? First, we have a nucleus. The nucleus is the central part of an atom, and it is what occupies protons and neutrons, and is positively charged for reasons that protons are positively charged and neutrons do not have any charge. So what is a proton? A proton has got a relative mass of 1 and it is positively charged. It determines the atomic number of an element and is found within the nucleus. What is a neutron? A neutron has no charge. It has a relative mass of 1 and it's also found in the nucleus, just as the protons. What is an electron? An electron is negatively charged. It is found outside the nucleus. According to Rutherford's atomic model, is that electrons are found around the nucleus, while in the Bohr's model is that electrons are in specific energy levels, what we called as shells. And we said examples are the K, L, M, and N shells that can only occupy a specific number of electrons. After understanding what is a neutron and what is a proton and what is an electron. Let us see the relationship between an electron, a proton, and a neutron in relationship to an element. The number of protons is equivalent to the number of electrons. The number of protons are equivalent to the atomic number of an element. The number of protons plus the number of neutrons are what we call as the mass number of an element. The number of neutrons is equivalent to the mass number subtracted from the atomic number. I need you to understand this before we go any further, that the number of protons is equals to the number of electrons, and the number of protons is equivalent to the atomic number. The protons plus the neutrons are what forms the mass number, and the number of neutrons is found as a result of the mass number minus the atomic number. So, for instance, you have an element like helium. Helium has got an atomic number which is equivalent to the number of protons of 2. The atomic number of helium is 2. The mass number is 4. That is the total sum of the protons and neutrons. So how many electrons does it have? The number of electrons is equal to the number of protons. Therefore, it has got the number of protons are 2, so are the number of electrons. But how many neutrons does it have? Remember, we said the number of neutrons is equivalent to the atomic number subtracted by the atom. It is equivalent to the mass number subtracted from the atomic number. That is 4 subtracted from 2, which is 2. Therefore, helium has got 2 electrons, 2 protons, and 2 neutrons. However, you can do exercises with other elements and see the differences between the number of electrons, the number of protons, and the number of electrons. Thank you.